Hello, good morning, dear students. Today, once again, I'm here with your chemistry class, and this is again, I'm introducing myself. This is Siva Tamrakar, Kendri Vidyalaya number 2, PGT Chemistry. And I hope you have learned the last session. And I asked you on that day that I will start my session with your test because learning testing is very important. The last class, just in a quick review, I'm going to give a glance for the revision. Then I'm going to take the test. I'm just your helping hand. That's why always assisting you. And this is the comparative chart for the solution, colloid, and the suspension. You all can see the first parameter that is written here over is the particle size. The size of the particles is given in the meter. This is the size of the particle, 10 to the power minus 9, less than 10 to the power minus 9. If the particle size is, it will be the colloid. If the particle size is between 10 to the power minus 6 to 10 to the power minus 9 meter, if I say in the nanometer, less than 1 nanometer solution, 1 to 1000 nanometer is the colloid, and greater to that, here in the case of meter, 10 to the power minus 6 is the suspension. In the terms of the nanometer, it's greater than 10 to the power 3, right? Then some more properties you can see here. Separation, but the ordinary filter paper, you cannot separate the components of the solution and the colloid, right? But you can separate the components of the suspension by the special type of the filter paper that is called the ultra filter paper. Please read it very carefully. Good morning to all the dear students. Because this property today I'm going to use in the preparation method also. A special kind of the filter paper is there that is exactly like the semi-permeable membrane, right? The pore size is selectively sized, right? So for with the help of the ultrafiltration, the solution cannot be filtered out, its component cannot be filtered out, but both the colloid and the suspension can be filtered out. By the nature, it is homogeneous. The colloid is heterogeneous but appears to be homogeneous, and at the same time the suspension is heterogeneous, right? Tyndall effect and Brownian motion, as I will take the properties, with that only I will discuss with you, okay? And then I have discussed the different types of the colloid on the basis of the dispersion medium and dispersed phase. The solvent of the solution is equivalent to dispersion medium here. Dispersed phase is the solute, right? And on the basis of that, we have categorized it into 8 different categories. And I told you on that day that most of the questions are asked on the basis of this dispersed medium and dispersed phase, right? Dispersion medium, dispersion phase, you have to identify in the given particular examples. Then on the basis of the affinity or interaction with the between the dispersion medium and dispersed phase, right? Lyophilic and lyophobic, these were the 2 categories. On the basis of the medium, the dispersion medium, names may vary: hydrophilic, hydrophobic if the medium is water or aqueous chicken, right? Alcohol, alcoholophilic and alcophobic, these are the terms used. And on the last session, I concluded with the classification based on the size of the particle, and 3 categories I have taken there. One was the macromolecular. The particle size itself was of the range of the colloid, but the 2 were different one. One was the multimolecular. A single molecule size was not in the range of the colloid, but when the cluster of the molecules are there, they behave as the colloid. When small molecules, they make a group of the molecules together and they form a multimolecular type of the colloid. The last one for which I have used one term and left one term missile, right? The some colloidal solution that in the low concentration behaves as crystalloid or electrolytic solution, but if its concentration is raised to a definite label, a minimum label, it behaves as a colloidal solution and it is called associated. Only the missile word I have used on that day. I left this because so that you do not get confused with the multimolecular and associated. Missile is the word for the used for associated when in the dilute state. Okay, when the concentration is low, they behave as the crystalloid, but to a definite level, after a definite level, they start behaving as the colloidal solution. This is just a quick review, and I'm going to give now you a small test. 5 questions I have written here, and you will give 5 marks to yourself, right? Please read the questions, take a screenshot for your convenience, whatever you wish, it's up to you, right? Now, you will get 2.5 minutes, right? Maximum the 3 minutes. The questions are very small one, right? You can write it very easily. Your first question is, what is the size of the particles to be called colloid, right? Unit, you can use meter or nanometer. The second question is, name the minimum temperature. That's why I have hidden these 2 facts here when I just revised you with the associated, right? What a particular term is used for the minimum temperature, okay, that is required to convert a crystalloid solution into the colloid. Just above to one definite temperature, the crystalloid behaves as a colloid in the case of missile. That particular term you have to mention here. Now, the third question is just your CBSE question as it is asked, right? Name the dispersion medium and dispersed phase present in the given set of the colloid, and the colloid that is given to you is the butter that you eat every day in your breakfast. You prefer to have with the bread, you prefer to have it with your all favorite snacks, and shampoo that you use in your daily life. I just want to give you these examples so that you remember the things that we use in our daily life are better to understand. The fourth question is, what is the CMC? Concentration for soap solution. CMC, here 2 tricks are there. First, you must remember what is the full form of the CMC, right? And then the numeric value, the number range. Okay? Are you solving the questions? One more minute I am giving to you, then I am going to discuss the answers. And please, you will give the marks to yourself. And I will be very happy to see the name of the students who will score 5 out of 5. Santosh is not interested in solving the question, and beta, if you are not interested in solving the question, you won't be able to earn the command over the subject. If you really want to earn the command and you want to use the class with the learning outcome, you have to do the practice. Okay, if you are not getting the right answer, you just try. Giving wrong answer is not a crime, but the crime is not to attempting it. Okay, if you are, why we are here, we are just here to help you only. So if you are taking the efforts, definitely you will be successful, but no gain without the pain. If you are not taking the pain of learning, turning the pages of your book, no. Santosh Kushwaha, you are in class 8, so I think you need not this class. This class is for the class 12. Now I'm giving you the answer. Please check your answers. What is the size of the particle? If I'm saying it in the terms of meter, 10 to the power minus 6 to 10 to the power minus 9. If I'm saying it in the terms of the nanometer, 1 to 1000 nanometer. Name the term that particularly is used here. For the second question, name the minimum temperature required to convert a crystalloid into colloid. This is the Kraft's temperature. The term that we use here is the Kraft temperature. The third question, name the dispersed phase and the dispersion medium present in the butter. Butter is an example of gel. Okay, medium is solid and the dispersed phase is liquid. Shampoo is an example of the emulsion. Liquid into liquid to immiscible, right? Two immiscible liquids, they form together the emulsion. Last one, what is the CMC concentration? The CMC represents here the critical missile concentration, and it's a value that is here 10 to the power minus 4 to 10 to the power minus 6 molar. How many of you scored 5 out of 5? Okay, don't, you need not to reveal here, but you assess yourself. Really, if you will assess yourself, you will learn the things in the proper way, right? So now I'm coming to my next topic, the methods of preparation, right? The methods of preparation for the colloid. Two categories of colloids are there. One is lyophobic and other is lyophilic, right? Lyophilic colloid, you all know that they have affinity. The dispersed phase has affinity with the dispersion medium as you prepare the solution, right? What you do generally, you take the solvent and then you add the solute. By that simple method, dispersion method, this kind of the colloids can be obtained. But the lyophobic colloids, right? Lyophobic colloids do not have the affinity with the dispersion medium. For that particular case, right, you need to apply the special methods over there, and these methods are effective for the preparation of the colloids, right? You all know that there is a range of the colloids particle, 1 to 1000 nanometer that I am writing, right? If the particle size is less than 1 nanometer, right, in that particular case, the method applied will be different. What you have to do there? In that case, you have to increase the size of the particle. But if the size of the particle is, if the size of the dispersed phase is better, I must use now the perfect terminology so that you also become the habitual of these terms, right? If the dispersed phase, right, has a size less than 1, the method applied will be different. And if the size of the dispersed phase is greater than 1000, that means you have to reduce the size, you have to smallen the size of the dispersed phase. So on the basis of this size, if the size of the particles is greater to the size range of the colloid, right, in that particular case, what we do, we have to divide it into a smaller size of the particles. That means you need the disintegration method, decomposition or dissociation methods there, right? And if this particle size is less than 1, that means you have to increase the size here. That for that purpose, you have to condense the particle. What method you have to apply? You have to apply the method, okay, in which the particles are going to combine together, so that by combining together, their size become greater and they fall in the size range of the colloidal size, right? And for this purpose, two types of the methods are there. They are categorized into the two different kinds of the methods, right? First method, one method is the categories, better I should say, one category is the decomposition, Or the second one is the condensation. Right? This is association. This is the disintegration. Simply, if the particle size is larger, you have to divide it into smaller particles, right? You have to convert it into the small pieces, right? And if the particle size is small, you have to increase its size. This is the only thing, right? And here, three very important methods are there that we have to discuss over here, right? And accordingly, you can convert them, you can write them in the given these two categories over there, right? One very simple method is there that is known as the peptidation. What we call to it, we call it peptidation. Do you have some idea of the precipitation? When two liquids are mixed together, the example I'm taking here, right? I'm taking the solution of one salt here, right? And then I'm going to add another liquid into this, right? Another solution I'm going, this is a barium chloride solution, very easily available in your labs. This you can see. This is the change. What has happened? Two liquids you have taken together, you have mixed two liquids, and what you see that now one solid is formed, right? One solid, this will deposit at like this. I did just few minutes before starting of the class. Now you can see this is heterogeneous. This is suspension, right? And you have to convert this suspension into the colloids. This is called peptidation, just opposite to the precipitation, right? What is precipitation? When you mix two liquids and you get a suspension, right? One substance, it deposits, it settles at the bottom, right? This residue, this is called the precipitate that you can see here, right? This is the precipitate, right? This is the filtrate, right? So if you have, you can see it is suspension because the particle size are greater to the particle size of the colloid, right? For this purpose, right, there, especially whenever you are getting the fresh precipitate, is you can take the example of iron, right? If you want to prepare the colloid of the iron, here one equation is also written. Ferric chloride, it is treated with the water, right? Hydrolysis takes place, and the precipitate of FeOH3, the ferric hydroxide, is obtained. Now, your intention is not to obtain the precipitate. Your aim, your objective is to prepare the colloidal solution of iron. So, for the sake, what you have to do, you have to filter out this precipitate, right? What you have to do, you have to filter this precipitate, right? I'm taking it. Okay. The peptidation is conversion of this precipitate. The precipitate, some of the precipitate, knowingly I have left it over here so that if I'm not getting it, taking it from the filter paper, then also I can use this method. I can demonstrate you this method. Now what I have to do, I just have to take the suitable solvent, better I should say the dispersion medium. This precipitate, it is added with the dispersion medium that you want to use for the preparation of the colloid, and along with this you need to add some salt here, right? What is the reason? You need one electrolyte to prepare this colloidal solution, right? And that is called the peptizing agent. What happens actually, these particles are charged one, right? And if the charge is opposite, again what can happen, they can attract together and they can get settled at the bottom. So what we do, we use some of the, now I'm just using the water here as a dispersion medium, and now I'm going to use the small amount of the NaOH or KOH or any other electrolyte that is of the suitable nature that you have to add from the outside. Simply you have to shake it like this, right? And this is your colloidal solution. Such a simple is the exercise. Simply what you have to take the freshly prepared precipitate, and this freshly prepared precipitate is to be converted into the colloid, right? This is called the peptization, right? Peptization is the process of converting a precipitate into the colloidal solution. This method is the peptization, just opposite to the precipitation, right? The precipitate, the precipitate, always it is a suspension, and that means its particle size is greater to the particle size of the colloid. That means now you have to divide it into the fine particles, right? This comes under the decomposition or disintegration methods, dissociation method. Simply if I say what you are doing it here, you are dissociating it, right? And the first method that I have taken here is the peptization. How you can define this? Peptization, the method to convert, the process to convert a precipitate into the colloid, a freshly prepared precipitate into the colloid is called the peptization. The simple 1 mark, 2 mark questions are asked and theory based questions are asked in the CBSE exam from these points. By the name these questions are asked. These are again your threshold energy questions, the questions that help you to cross the threshold barrier of the 23 marks without getting failed. You can answer these questions. Such simple concept is there. What is the concept? What you have seen? Simply a precipitate, okay, it is added, it is dissolved, it is dispersed in the dispersion medium, and one suitable electrolyte is added there. And what is the role of this electrolyte? The role of this electrolyte is to increase the stability of the colloidal solution. What happens actually here? Okay, if suppose here if there are two particles, right, and they can combine together, but this opposite, this electrolyte, what will do here, it will form a layer of the negative or positive depending upon the nature. That's why I said that it depends upon the nature. In this case it will form a negative layer here, right? And two negative particles, now they will not come into contact with each other, they will repel to each other, right? And that's why now the association will not take place. The particles will remain far away from each other. The particle size will be smaller now, right? What has happened during the precipitation? They have come close, and because of that, what has taken, association has taken place, and because of that the particle size has increased and they were settled at the bottom as the precipitate. Just opposite you have to do. So what you have to do, you have to charge them with the same charge, right? And for this purpose we add the electrolyte that is called the peptizing agent, the peptization agent, right? So this is the importance of the electrolyte. right? It prevents the association of the colloidal particles, otherwise they will again get coagulated. To prevent the coagulation phenomena, we add some of the electrolyte from the outside, and this totally depends upon the nature of the colloidal solution, what content you have taken on the basis of dispersion medium and the dispersed phase, right? So this is one important method that I have discussed here. Now you can, I think you have understood this falls in the first category, right? Now I'm going to tell you the second method of the preparation of the colloid, right? And here by name method is there. It is again a method that is asked by the name, that is called Breding's arc method, right? It is electrical arc method, right? Electrical arc, are you familiar with this term? Arc, arc, fire, एक चिंगारी, एक spark. I think you have seen sometimes the wrong wires are connected together. Okay, as they touch, two wires touch together, what happens? One spark is produced, and this spark is called the arc, right? This is the arc. The complete chapter is very easy one, simple in the 2-3 sentences you have to answer, right? And the term particular which are used, you have to use for, right? This is the only story here, no big deal here, right? The next method that you have to use is the Breding arc method. Arc, because electrical arc is produced here, that's why the arc is named. The scientist, how you can forget to give the credit to the scientist who has done this wonderful job. So that's why it is called the Breding's arc method, right? And this comes under the context, two phenomena takes place here simultaneously in this method. One is the dispersion and other is the condensation. Although I cannot show you the complete and exact setup, but just a small idea I can give you of this setup. I'm accepting before all of you, it is not the complete setup, it is just how to show you how this can be done, right? It is just to show you the, here you can see two containers I have taken, two beakers I have taken, right? This one is small and a large one, and in between the ice is filled, right? I have made the ice jacket or the ice bath, right? In the Breding arcs, this system is used, right? Dispersion medium is taken in the inner surface, and this method is applied especially for the metals, right? When you want to prepare the colloidal solution of the metals, in this case especially gold, silver and platinum, this method is applied. That's why I have taken the spatula. A spatula, you can consider it as the two rods of the metal, right? Two rods of the metals are taken in this. They are dispersed, right, in the dispersion medium. Whatever the dispersed phase you want to take, the colloidal solution of what you want to prepare, those metals are taken as the rods here, the rod of those metals. They are dipped in the dispersion medium in which you want to prepare, right? And this is, what is the role of this ice jacket? These are connected with the battery. One end is connected with the positive terminal, one rod connected with the positive terminal of the battery, and the second rod is connected with the negative terminal of the battery. So definitely one will behave as an anode, other will behave as the cathode. Now you bring in the contact of each other like this. Okay, if cathode and anode are going to touch each other, definitely it will produce an electrical spark. What will happen? The metal will evaporate. The energy, the heat that is produced, that will cause the evaporation. It will melt down and evaporate, and this will leave the surface, right? You want the gold, you want the silver, you want the platinum, such expensive methods, and then if it has left the surface, it is all useless. For this purpose, this ice cold jacket or the ice bath is used, right? Dispersion medium you take in this, right? The inner one, then this is kept in the ice jacket or ice bath. So as soon as the evaporation takes place, this temperature, this helps in the condensation process, and simultaneously vaporization, dissociation, everything takes dispersion and the condensation takes place, and that helps in the preparation of the colloidal solution, right? This is the arc method, breeding arc method, right? The ice cold jacket, always in this setup, the instrument, the device, it is not the exact device, just I wanted to show you how this takes place, right? I can draw the diagram in the blackboard, right? This part is filled with the ice, right? Two rods of the metals are taken here, right? They are connected with the battery, right? This part is filled with the dispersion medium, the inner vessel, it is filled with the dispersion medium, right? What happens now? Now this, both the metals, these are the rods of the metals of which you want to prepare the colloid. If you want to prepare the colloidal solution of the gold, take the rods of the gold. If you want to prepare the colloidal solution of silver, take these rods of the silver, right? If you want to prepare, this method is especially applicable for the preparation of the colloidal solution of the metals, and especially these noble metals, right? Now, one of your rod is behaving as the anode and one of your rod is behaving as the cathode. As they are connected with the battery, different terminals are there, right? When you bring them in the contact of each other, right? As they come close to each other, what happens? An electrical spark is produced. This electrical spark, right? This electrical spark causes melting and evaporation of these metals, right? The high amount of the energy is released when the electrical spark is produced, right? And definitely it will be in the gaseous form. Now I want to convert it into the proper colloidal solution in the liquid state. This ice cold jacket or this ice bath, it lowers the temperature at the same time, right? And because of this, what happens? The vapors are condensed to the small size particles, right? And the size of particle is of the colloidal range. So this method, the method of condensation and evaporation, right? What happens here in this, right? In this side, in the inner vessel, what you take? You take the dispersion medium. Okay, the dispersion medium in which you want to prepare the colloidal solution, you fill it in the inner vessel, inner container, right? The disperse phase, right? You take as the rods, right? And both rods must be of the same metal here. Please do remember, both the rods must be of the same metal, right? And you have to connect it with the battery, right? You have to touch both the rods together, right? At the time they are coming into the contact of each other, what will happen? An electrical spark will produce, and this electrical spark has a lots of high amount of the energy is present there. This will cause the melting and evaporation of these metals, right? And this ice bath helps in the condensation, right? Small sized particles are dispersed in the dispersion medium. This is the Breding's arc method. Not a big deal. Simple. आपको क्या करना है? You have to take the dispersion medium in the inner container, dispersed phase as a metallic rod. You have to connect them with the battery, right? You have to produce the electrical spark, and as the electrical spark will produce, it will evaporate, vaporization will take place. But since the ice bath is present there, what it will cause? It will simply cause the condensation and the ice cold, and this colloid will be prepared. So what kind of the method is? It is association, dissociation. Very good. Now the third method I'm going to take is the chemical method. Chemistry, how it can be complete without the chemical reactions. Never possible, right? For the easiness, I have used already this part of the blackboard, right? We can perform some chemical reactions also to prepare the colloidal solution, right? On the basis of the reaction. What is the nature of the reaction? I think some terms I have written here, you're already familiar with this. Oxidation, right? Reduction, hydrolysis, double displacement, or double decomposition, right? These kinds of the reaction can be used for the preparation of the colloidal solution, right? We can prepare the colloids by the different chemical methods also, right? One example I have taken here, it is for the preparation of the sulfur. Okay, if you want to prepare the colloid of the sulfur, this method you can apply, right? Rather than the bromine, you can take the water also in the example, right? Oxides you can take. So it is just one example that I have taken. What happens here? You want to prepare the colloid of the sulfur, right? For the preparation of the colloid of sulfur, you pass the H2S into the bromine liquid, right? What you get here? HBr, right? And sulfur is produced here. And this sulfur, okay, dissolves with the reaction medium and it gives the colloid. Why I call this method as an oxidation method? Sulfur, what is the oxidation state of the sulfur here? Hydrogen, as usual, 1. So 2 hydrogen are here. So overall it has become +2. That means the oxidation state of sulfur is -2 here, right? On the basis of the substance or the dispersed phase, right? What is the dispersed phase that you want to take for the preparation of colloid? The name of the reaction is given. Okay, the name of reaction is always given on the basis of the dispersed phase of which the colloidal solution you want to prepare, not on the basis of the other reactants present in the chemical reaction. Definitely, if one is undergoing the oxidation, other it may be reduced, right? But since we want to prepare, what my objective is? My objective is to prepare the colloidal solution of the sulfur, and for this purpose what I have done, I have dissolved the H2S into bromine, right? And in this case what has happened, the sulfur was in the -2 oxidation state. Now you can see here sulfur is in the atomic state, that means its oxidation state is 0. -2 to 0. This is a positive change in the oxidation state. Always a positive change in the oxidation state is called the oxidation, right? -2 to -1 is oxidation, -1 to 0 is oxidation, +1 to +2 is the oxidation, 0 to +2 is the oxidation. So since what is happening here with the sulfur, the oxidation of sulfur takes place, right? And because of this, right, what happening? We are getting the colloid of the sulfur. Take another example, H2S plus SO2, What you can obtain here? H2O, of course. Balancing, if it is not, we can do it. Now, 3s, sulfur. Again, you got the sulfur here, right? Although I tried, and if it is not balanced, we will balance it. Balancing is not the aim at this moment. What our intention is to understand the chemical reaction that is going to take place here, right? When H2S is treated with the sulfur dioxide, again what happens? This forms the water and the sulfur is in the free state, that forms, right, that gets dissolved in the water and it forms the colloidal solution. So it's a chemical change that has taken place here. That's why this is a chemical method of preparation of the colloids. And since the oxidation has taken place within the dispersed phase, this is called the oxidation method. The second one is the reduction method, right? Here, this method is again very applicable for the noble metals, right? The metals which are less reactive, right? For that purpose, this method is extremely useful. Now, the gold chloride is treated with the tin chloride. AuCl3 is treated with the SnCl3. What is formed here? SnCl4, and along with that, you get the gold. That actually it is not written at this corner. Maybe it's not very clearly visible. That's why I'm writing it here. Here, what is the oxidation state of gold? +3. Since Cl is the minus unit, here what has happened? Now it has become its oxidation state 0, plus minus whatever writing, it's not, it doesn't matter, right? So what is happening here? You can see in this reaction the gold has converted from +3 to 0. So can I call it now the oxidation? No, this is the reduction. What has taken place here? A negative change has taken place in the oxidation state here, right? Here the oxidation state is +3, here and here the oxidation state is 0. +3 to 0 is a negative change, and that's why this is the reduction. Tin, although tin is in the +2 oxidation state here, it is converted into +4. But since I'm not preparing the colloid of this, I'm preparing the colloid of this gold. That's why I'm considering what the chemical change is taking place with the gold here, right? So one method is the oxidation, second method is the reduction, the third method is the hydrolysis. Hydrolysis means simply treating with the water. Simple, whenever you treat any of the reactant with the water, this is called the hydrolysis, right? You dissolve the thing, any of the salt in the water. This is called hydrolysis, and this actually reaction I have used for the preparation of the precipitate. The time I was showing you the peptidization method, right? FeCl3, right? When it reacts with the water, when it is dispersed in the water, what happens? FeOH3 is formed. Ferric hydroxide is formed, that is there, right? Since this reaction is carried out by the reaction with the water, that's why this is called the hydrolysis method, right? And the last one is the very important one, double displacement or double dissociation. I think in the class 10th, we have studied these categorization of the chemical reaction. What happens actually in the double displacement or double decomposition method? Both the salts, right? Both the reactants, they exchange their ions. Dissociation of both the reactants take place, and in such a way that they exchange their counterparts. What you can see here, here it is AgNO3, right? Silver nitrate, I think I can write this side, better will be AgNO3 plus NaCl AgCl will form the precipitate and NaNO3. Now what has taken place here? Silver plus 1 here, chlorine minus 1, right? Na plus 1 here, NO3 negative, NO3 negative. No change has taken place in the term of the oxidation or reduction, right? Neither you have treated is with the water, right? So what is going to take place here? The double displacement or the double decomposition is going to take place here. The NO3 is exchanged with the Cl minus, right? I want to prepare the colloid of the AgCl, and for this purpose I have taken the solution of silver nitrate, I have treated it with the sodium chloride. Now I got the colloid of the AgCl, right? This has also undergone the decomposition. It has also dissociated, and NaCl has also dissociated, right? Both of them have exchanged their parts. The Cl has moved with the silver and the nitrate has moved with the sodium. So here again, this is the last method to prepare the colloidal solution with the help of the chemical reaction, right? So this is called, right, three different methods we have studied for the preparation of the colloids, right? Mainly these three methods are there. One more method is the mechanical method. Okay, if the size of the particles are simply, it's like the grinding, right? The mechanical dispersion method is there, right? And in this mechanical method, what takes place? You take the dispersed phase and you have to pour it into the mechanical. Simply, it's like the mixture that you use the mixer here, or the mills, the flour mills. You can make it equivalent to the flour mills. Like the wheat is poured there and then it is grinded into the fine powders and that fine powder comes out. In the similar way, the mechanical method is also used, and this mill is called the colloidal mill, right? So four different methods. Two categories are there broadly. If we divide the methods of preparation of the colloid, there are broadly two methods. One method in which the size is increased, right? That is called the condensation method, right? And the second method in which the size is made smaller, that is called disintegration, decomposition, dispersion. These are the name of the methods. And under these categories, and these are applied for the lyophobic one, right? For the lyophobic, we use these methods, right? So here I conclude my session today, right? I just wanted to teach the method of purification also, but I think now the time will be over and it should not be in the hurry. I'm just recapitulating, right? For the lyophilic colloids, no special method is used there. Simply by the dispersion of the dispersed phase in the dispersion medium, right, you can prepare the colloid. But for the lyophobic, you need the special methods as they don't have the affinity, right? The dispersed phase and dispersion medium, they don't have affinity together, and that's why for this purpose you need to apply the special methods. And these methods are divided into the two categories: condensation, dispersion, right? I started with the terms that you are familiar with. Now I have concluded with the typical terms used, right? And in this breading arcs method, in the breading arcs, this method is applicable for especially gold, silver and platinum, right? Metallic rods are taken and they are connected with the battery. This is kept into the dispersion medium, and dispersion medium is itself kept in the ice bath, right? So by that, peptidization, just opposite to the precipitation, a freshly prepared precipitate is dispersed in the dispersion medium along with the some electrolytes, and these electrolytes increase the stability, right? What is the use? The very, very important question for the test that I will take on the Wednesday, right? And then some chemical methods are applied, right? On the basis of the nature of the reaction that takes place, different categories are there: oxidation, reduction, hydrolysis, and double displacement. I think you have understood. If you have any problem, you can ask, you can put your queries in the live chat session. And Wednesday, I will be back with you with the purification method and the properties of the colloids. Thank you and have a nice time.